Welcome back. I hope everyone is enjoying all of the amazing sessions so far. Next up, we have a great lineup of speakers here to discuss the challenges that enterprise data science teams face. Please join me in welcoming all of our amazing speakers to the stage.
All right, thank you so much, Rachel. Hello, panelists. Hello, attendees. As Rachel said, we have a wonderful panel coming up filled with knowledge, and I couldn't be more excited. I'm Daniel Lackman. I'll be the moderator for the panel session today. And without any further ado, we'll go around and do self-introductions. Gorkem, I was wondering if you would do the honors and give a self-introduction for us.
Of course. Thank you for having us here. My name is Gorkem Sevinc. I am the founder and CEO of a company called Qualytics. And Qualytics is focused on data quality surveillance for the enterprise.
Excellent. Thank you so much, Gorkem. Sahar, would you like to give a self-introduction for the crowd?
Thank you very much, Daniel. Yes, I'm Sahar Asadi. I'm AI research lead at King. And I've been working in the industry for the past 9 years in machine learning and data science, and I'm happy to be here.
Excellent. Thank you so much, Sahar. We're very happy to have you here as well. Dev, would you like to introduce yourself for the crowd?
Yeah, thank you. Thanks for the invite. This is Dev Bapat. I lead the data science and engineering group for medical devices within Johnson & Johnson. I've been in this role prior to that in supply chain for almost over 5 years now.
Excellent. Thank you so much, Dev. And last but certainly not least, Daniel, would you like to give your self-introduction to the crowd?
Thank you very much, Dan. Hello, my name is Daniel. I am the head of AI and machine learning for commercial banking at JPMorgan Chase. I'm also working very closely with Stanford University developing their AI professional program. Glad to be here.
All right, this is going to be a wonderful panel. For any attendees watching, whether you're a data scientist, whether you're working on a technical team, we hope that this panel is enlightening in one way or another. Rachel, without any further ado, would you like to jump into question number 1? Okay, great. So just to kick us off, and Dev, this question will be coming to you. AI is hard. How do you know when a project is worth the investment of resources?
Yeah, so that's a general question, right? And in many cases, as you're aware, many of the AI projects fail, and there are different reasons for it. And you always have to take some risks, otherwise you don't know what's going to succeed. But over a period of years, there are some patterns that have started emerging, and that's the lenses that we generally look through around the type of project that we take. Can we build a product out of it? What are the benefits? But the biggest ones have actually nothing to do with algorithm or even data, quite frankly. More of them have to do with the ability of the end users, ability for us to identify the end users, making sure that the end users are empowered and there is a feasibility to drive change and adopt the AI algorithm into their daily decision-making processes. And in general, what we have seen is if that feasibility and ability exists, then there is a higher probability for those AI projects to succeed, which is then weighed heavily on us or weighed heavily by us to make sure that those are the projects that will be definitely worth our investment.
Excellent. Thank you so much for that perspective. Would anyone else like to jump in on this particular topic? Feel free to jump in.
I would love to jump in. So in my experience, I think it just really depends on multiple factors, right? So I would echo everything that Dev said here, but also like, how big is my team? How mature is my infrastructure? How trustworthy is my data? Do I have to do a lot of cleanup before I can test out the model that I'm considering? Is my company data driven? Do I use AI and machine learning to make decisions on a daily basis, or is this a scientific experiment? Is this more of a production thing? I think all of those actually go into becoming factors before I can decide if the ROI for this makes sense.
Can I jump in and add something more?
Of course, Sahar, go for
it. So, I mean, those are really good points that both Dev and Gorkem mentioned. In addition, I think what I've learned is that very often you need to, as a machine learning researcher or lead, you need to also be very close to business to understand the needs of business. So having this domain understanding and continuous conversation with product and business enables you to secure that your project is in the right direction and worth the investment. And another question that we usually ask ourselves is that does this become something critical in the next 1-2 years for the company and requires us to look at it with the long-term lenses? And that's another perspective that we consider.
Excellent. Thank you so much, Sahar. Anyone else want to jump in before we go to the next question on how to determine if a project is worth it?
I would like to chime in, providing additional ideas around this. Obviously, ROI-driven, business priority-driven are very important, but also think in the aspects around reusable data assets and technology, right? And so in this day and time, you want to look, what are the things that we can focus on and that would enable a long-term innovation rather than just very focus on the one-off solution. So that's one. And for companies like JPMorgan or financial service company overall or banks, we are highly regulated. And so that governance aspect is also very important to think about, how does this project tie to the overall regulatory requirements and plan accordingly? Because, certain ideas may not even be legal or feasible or good to do given the current circumstances. So that's an important thing to think about upfront.
Excellent. Thank you so much, Dan. Rachel, would you like to jump to the next topic? Okay, great. So Dan, also, I would love if you could kick this one off as well. The question is, what challenges do you face when it comes to human resources? Do you find it hard to build an effective team? And how do you deal with these challenges?
Sure thing. This is a very, very big question, and the answer would be very long, but I would just say this is a very common problem in the industry. In fact, several reports that were released recently all point to the challenges of recruiting and retaining the AI talent. So specifically, just last year, Deloitte released a report on state of AI in enterprise. And basically, they grouped the AI talents into 3 categories, right? Very seasoned AI experts, skilled AI practitioners, and just starters, people who just got their degree and get into the industry. What they found is across the board in all 3 categories, there's significant gap, meaning that companies are reporting that they are having trouble recruiting talent. So that's one data point I think worth pointing out. So if you feel the pain, you're not alone. The second report that was released also pretty recently by Tencent Holdings, focusing on just AI talent distribution. And the information is quite alarming because what they found is around about 300,000 AI practitioners and researchers around the globe, and with specialized experts, about 36,000 experts. 50% of them are all in United States, and 36% of the AI experts in the United States is located in Silicon Valley, and 20% of all AI experts work for tech giants. So this points out another issue in distribution of AI talents. For other companies or in other geolocations, the problem of getting sufficient talent or the type of talent you need is even more severe than those that are faced in the United States. So how do we deal with this kind of problem, right? So obviously recruiting is pretty competitive. These days, what I'm seeing is that, the compensation is pretty erratic, and it's almost in terms of, it's almost like a bidding war for talent, especially for very strong talents, and it's pretty much out of norm. And another area that I see, I'm seeing is that, especially for experienced experts, right? These are very, very hard to find, and it's very, very hard to retain them as well. And so, a couple suggestions or things that I'm doing with my team is obviously one is, focusing on what market is trending, where market is going, and find out, what type of talents that we need. And to the extent that we could enable upskilling within JPMorgan Chase, they're very capable folks who are already very good engineers. We will, train them to get into machine learning, and vice versa. We have very skilled analysts who are very good data workers, but lacking engineering skills, and we can upskill them as well. So that's one way for perhaps larger organization to be able to mitigate this issue while trying to recruit from external resource. Another thing around retention is really have that clear career path, for whoever you recruit. People want to have room to grow. They want to be challenged with, real impact projects that are technically challenging, but at the same time, they can see the business impact that the product of the work can actually get into the hands of the user. So I think these are all very important factors for any managers or leaders to consider in terms of building a strong team.
Excellent. Thank you so much, Dan. Would anyone else like to weigh in on this topic?
I would love to start, if that's okay. So I've built a ton of teams, and I've built a lot with software engineers, especially, and some with data teams. And I have a few thoughts that I would love to share. Number one, I think it's very important to build the right kind of team culture for innovative work. These are knowledge workers. I lean on Dan Pink's principles in Drive, where he highlights mastery, autonomy, and purpose as the three drivers for knowledge workers. And we need these to drive innovation to new heights. Of course, empathy is part of this as well. But with mastery, autonomy, purpose, we look at, do they have the expertise, or do they have the potential to be experts in this field? Are they doing stuff autonomously? And do they really believe in the purpose of what we're doing? Do they internalize the goals of the company? That, of course, along with empathy and culture fit are very important things. Number two thing that I would like to highlight is scientists, engineers, and analysts are different roles. So I get Daniel's point that sometimes people like to move from one to the other because they are actually graduating into the next level sort of thing. But when we are hiring people, we need to understand that we cannot expect an analyst to do a scientist work from the get-go, right? And we cannot do the vice versa either. So we need to understand better the difference between scientists, data engineers, data analysts. We need to highlight that. I like to highlight that, especially for data engineers, I like them to be less opinionated about the specific tech that they like to use, because we engineers, we love to be super opinionated about, I only do stuff in scikit-learn, I will never touch TensorFlow, that kind of stuff. But we need to be less opinionated so that we can be flexible in an enterprise environment. And the last point I wanted to make is, again, a response to Daniel's point on how do we keep the data scientist migration to San Francisco? How do these people are introverts. They go for the easy approach with tech giants, and tech giants are offering, of course, everything to them. So we need to flip the script like we did for software engineers over a decade ago. Over a decade ago, that migration was happening for software engineers quite a bit, and now they are everywhere. And I hope that we're going to succeed in doing that with data scientists.
Yeah, I think most of the points have been covered. I think it is about the talent identification, retention, and also the right fit within the company culture. One thing, just to building up on what Gorkem said, right? Sometimes companies, so there are two problems that I've also seen. Because data science is a hot commodity, that's almost like everybody or every group which has some budget thinks that if we just hire a couple of data scientists, things would be good. So in a large company, which is decentralized, sometimes you just have too many groups hiring data scientists. That causes some confusion. The second part is sometimes companies, again, because data science is a hot commodity, going back on Gorkem's point, they over-index on data scientists and AI ML folks versus looking at it as a complete product and what would be the supporting cast that would be required in order to make that algorithm successful, build a product out of it and embed it into the product or a process. So those are some of the things that organizations should also consider. It's hard because data science gives you, or AI gives you, some immediate results that businesses can act on, whereas converting that into a full stack product will take a lot longer and will not have any results for at least 1 year. So that's a leap of faith that many physical product companies are willing to do it in, like an R&D type project, where they have 5-6 years, but in a digital project, they have not yet been ready to take that leap of faith that you're going to invest in something that will not have any return for 18 months.
I also wanted to add one more thing. I think it was like all very good points that is common concern and practices for us as well. Another area that I want to highlight is hiring. The process of hiring. Very often ads, they don't really match the requirements that the enterprise or the company has for a specific role. I've seen, for instance, I think it was last year, it was like a 13 years, like there was an ad looking for staff machine learning engineers with 13 years of experience. And that is something like, you know, the role of machine learning engineer didn't exist before. And if you find, for instance, a female candidate applying for this role, definitely doesn't apply because doesn't feel confident enough to apply for that, right? Because it doesn't match this criteria. So it's good to be rigorous and mindful of what kind of, you know, given that we need all this different spectrum of machine learning or data science and software development within the area of AI and machine learning, we should be a bit more mindful of how we put the ads out. And also, like, you know, being part of Women in Data Science, AI and Machine Learning community, having some investment and making sure that, like, you know, we understand how we can motivate and actually help them to get to know their roles and how they fit into these roles to apply more.
Thank you so much, Sahar. Rachel, let's have the next question. I really appreciated all of your responses there, and I'm excited for this next one. Okay, Gorkem, I was curious if you would kick off this question. The question is, why do so many AI projects fail?
Of course, we hate the word fail, but I actually love internalizing failing because you fail fast, fail hard, and then you go and do it better next time. Now, of course, there are many reasons for projects failing. Number one that I have seen is trust in the data. That means trusting in the outcomes, building that trust with the stakeholders so that they are from the get-go involved in the process, so they're not surprised by the results that they see because our model has built XYZ and it is not what they expected to see. That often gets to projects going to fail because, well, that's great, thanks for running that scientific experiment, right? We often hear that. Number two is presentation layer of AI findings, right? As machine learning AI researchers, we're more focused on the science, we're less focused on the presentation layer. People are visual, people are extremely visual, actually. We may not be the best people to visualize the findings of that we have. Of course, to each his own. This is just my experience. And number three, this is why I started my company, data quality, right? We spend so much of our time cleaning data to make sure that the data that we're putting into our models is correct so that we spit out the right results, that we need to automate that part of data quality checks because we're spending so much time on it. And if we cut any corners in checking data for its quality, our results are going to be skewed. Our results are going to be wrong. And we need to be better about that. And I have seen, unfortunately, a lot of projects fail because just the data was not trustworthy at the end of the day.
Excellent. Thank you so much, Gorkem. Anyone else want to talk about different reasons or some of the similar reasons why the failure rate for these projects is so high?
I think go ahead, Daniel. Go ahead.
Sorry. Yeah. So I would like to add two things. One is, related to, what Gorkem just said, right? I think not aligning the project to actual business OKRs or what business outcome that you want to achieve is one major problem. I've seen a lot of project states in POC, kind of stage and never see the light of day after past that. It's purely research and never get into the hands of the user. So that's one. The second thing I think is, lack of readiness, right? So by that I mean, a lot of times without the thorough analysis up front to see whether we even have the necessary data set to do the work, or whether we have the consumption distribution channel for this solution identified, and just jump into solving the problem too quickly without having that end-to-end strategy planned out. I think that's another reason that is, that a project could fail. And last but not least is again, I want to point out the governance and operation. It's not enough just say, I have the first version deployed. You need to think about in the long term, how do you support? It's not unlike any other software. Like, it has to be maintained, and actually the upkeep is even more expensive. And so really having that plan clear upfront is important. And the last bit is the governance piece. Again, many organizations defer that governance and risk assessment until it's about to go out the door, or even worse, after it goes out of the door. And the damage to the company or the issues that related to model risk or solution risk is going to cost the company greatly. And so these are the things that really need to plan carefully upfront.
Yeah, I think the only thing that I would like to add, I think most of the points are covered, is hype versus reality. I think a lot of times what we also see is, I look at senior executives across three spectrum. One that are really aware and curious and hence want to sponsor large AI projects. One that are not yet willing to jump in, which is actually okay. But then there is the third category who is in the fear of missing out. So they have been contacted by multiple large management consulting firms. They want to show some sort of AI ML. I actually, at one point in time, I still remember 4 or 5 years ago, there was a strong push saying you need to have Watson in. Now, nothing wrong with IBM Watson, but just having Watson in was not going to solve any of the problems. So that's where sometimes the AI projects also have a bit of a hype around them, and those are the ones that are most likely to fail. The other ones that I think were already covered, the only thing that I will add, which is what I said upfront, is also sometimes they may succeed on a temporal basis. But if people change, if the groups change, then they might not sustain, only because if they are not embedded into the process on a day in and day out basis.
Maybe I can also add a couple of points. One is that, this is the true story from past experiences, but sometimes, the scientists or machine learning engineers spend a lot of time offline looking at data, building their models, and then you get to a point that now I want to put this in production. And they haven't thought it through that, like, if I'm doing a real-time predictions, or I'm doing an online prediction, what is the requirement and what are the rest of the development production system. And this model and the data that went to the model actually doesn't really fit that requirement, and it fails. Another thing, again, from past experience, is that sometimes the world of machine learning, to build up on what Gorkem said, the world of machine learning is very disconnected from business. And what ends up is either business thinks that, oh, this is easy, machine learning does the magic, it takes only 1 month of work, while this is like a 6 months to 12 months work. And or it goes to a point of you build something successfully, the product owner doesn't feel the trust to put this model in the production because they don't feel comfortable with this black box, and you need to go hand in hand the whole project for them to understand what you're actually doing and how you present your analysis to them.
Excellent. Thank you so much for jumping in, Sahar. Rachel, let's go to the last, or not the last, the next question. Okay, great. So Sahar, actually, I would love to kick this one over to you as well, if you're okay with that. The question is, what is the best way to scope a potential new AI project?
So I'll kind of relate to the previous discussion and question we had. I think it's important to start when scoping the project, to start thinking end-to-end and start with a very simple model, but build an end-to-end system that you understand, like, what would be the needs of production, what are the needs of business, and you get all the reliability, and then start making the system more complex. And then I think it's also important to have some proxy metrics that gives you an estimate about what would be the business impact when you put this, when you turn on this model in the production system. So you need those kind of estimates early on. One of the good, there are a few tools that it can be used for defining and scoping projects. For instance, going through tools such as ML Canvas, it will help with answering these questions early on and get a better understanding of what are the gaps in our understanding and how we can scope and define the steps of projects. One of the exercises, for instance, in our team that we do is that we break down the scoping of a big project to 4 phases. We say discovery, proof of concepts, prototype, development, and operation. And so the discovery phase is the phase that we spend, make sure that we don't spend a lot of time, so maximum of 1 month, and looking at answering the business questions, potential impacts, what work exists out there, without going crazy with a very complex system. And then if we get approval from business, then start scoping something more complex and iterating over that. So these are potential ways that I think they could help.
Excellent. Thank you so much, Sahar. Anyone else want to jump in on scoping a new project?
So I'll give it a go. Sahar mentioned many different very good points there. I would just like to add something that I said earlier as well. Data readiness is really a key. You don't want to just jump in a project prematurely. Really that evaluation of what you have available to you to do the work and assess whether that will get you, to be able to deliver the business OKR is very important to spend time on. A lot of times I see scientists just, take whatever is available and start attempting solving the problem. Nothing wrong with, doing a simple POC and come back and say, this is not enough. But if you go like full steam, forward and trying to take months to develop a project or a solution for the problem, you may just end up wasting all your time. The second thing I think is to have that agile mindset. A lot of times the problems that we're trying to solve is super complicated. It's very, very large scale. And nobody really can see clear to the end, the path. And so the ability to fail fast and pivot is super important. And that's exactly, the agile kind of mentality comes into play here, is that the team need to be able to, be okay with we fail several times until we figure out, because sometimes those experiences are exactly what you need to learn more concrete and specific directions that you should be taking, because a lot of times you find stakeholders not able to provide very concrete requirements because they don't know either what's possible. And it's sort of like a learning journey that inevitably needs to happen. Last but not least, I would like to caution teams that tend to spend unlimited amount of time on research. Typically, I tell my team to time box the research effort. Like, you can research forever and still not see, a path forward. The best way is just to have something working and then test it out and then learn from that result and then iterate through multiple times. So those are my kind of thoughts on this.
Thanks so much, Daniel. Dev or Gorkem, you want to jump in on this before we move on to more focused on data preparation and governance and stuff?
No, I think we're good. I mean, this Sahar and Daniel
Yeah.
covered it so well that I'm just going to repeat the same points.
Yeah, definitely. You're all giving excellent answers. All right, Rachel, let's go ahead and jump to the next topic. I know this has come up a number of times, so I'm really excited about this one. Dev, I'd be curious if you were open to kicking this one off. The question is, what is the best way to approach data collection and preparation?
Yeah, I think there is one step before that is what I would argue, even before data collection and preparation, is the problem scenario identification. Generally, what we have seen, what works better is when you walk yourself in the shoes of the person who actually has the problem, and when you map the process, you generally are aware as what data might come up. At least you have an initial hypothesis. I mean, there are two ways to do it. One way is to just collect a lot of data and see what pattern emerges. And one way is to be a bit more targeted. Both approaches have worked, so long as you know what are the first steps that you want to take a look at in mapping the process, what data has come as critical. The second part is that data is going to be wrong. That data is not going to be complete. The other thing that when that process mapping happens, what it also helps is, what we have learned is sometimes data, if it's in silos, that's actually a good representation of your organization structure. So what ends up happening is if your data is in multiple silos and represented in a different way, there is a good chance that different functions that are owning the data are also operating in a silo, which means that when you have to deploy your model, operationalize it, and kind of integrate into the process, you know what challenges you are going to face. So that actually also helps you, and hence mapping that upfront is important. We go with generally with a mindset that data is going to be wrong and data is going to be incomplete. But this actually helps us understand the business processes better, because the more, if we actually encourage our data scientists to go through that exercise, it is very painful exercise for the first 5-6 weeks, but it actually then helps you to pick the right algorithm and tune it to make it a fit for purpose solution that can then be adopted by the business.
Excellent. Thanks so much, Dev. Anyone else want to jump in here?
I can jump in real quick. One thought that is, well, I'm in this world, right? The data collection and preparation world, where we spend a lot of time with cleaning data and actually finding anomalies within data that before it comes to the data scientist. Now that being said, I think one of the things that we see often is does the company, does the enterprise have a mature infrastructure that enables data scientists to do their work, right? Do we have the data in the right place at the right time, or are they having to Dev's point, are they trying to herd the cats, trying to get all the data that they need so that they can actually do their work? And it's unfortunate that in the industry, it's between 75 and 80% of a data scientist's time is spent with data collection and preparation, and that is not value add, right? It's a lot of it is unfortunately spent on stuff spent on tasks that are not using the data scientist brain, and that is a little bit unfortunate. So if the company has made the necessary investments to enable that kind of AI ML sort of work, if they have they made the infrastructure pieces, the software pieces in place, that's great. If they have invested in a data quality, data observability platform that at least goes after the low-hanging fruit of anomalies that then the data scientist doesn't have to weed out of their models, that's great. That's the second line of defense that enables them to do more. So so I think, you know, there are more and more tooling that is coming about for enabling our data scientists to focus more on their value add. And I would always encourage people to keep up to date on the recent happenings.
Thank you so much, Gorkem. Anyone else want to jump in here?
Yes. You know, for machine learning and at least most of the AI project, getting the data right is like get you almost there, like halfway there, right? So an interesting data point to share is like, you know, a couple of years ago, actually 2017, Kaggle released a survey, right, based on state of data science and machine learning. You know, so they surveyed the practitioners, and what they found, the key challenges for data scientists across the board, 50% of the folks responds that dirty data is the #1 challenge for them. And then 30% thinks that the data availability is a big problem for data scientists. So this shows the very serious problem. And if we could solve these problems, it would increase productivity and effectiveness of our data scientists greatly. Now, the second thing I want to talk about is, you know, so that's related to quality of data, right? So, you know, and that's kind of tied to the point I tried to raise earlier, like the readiness of the data. A lot of organization hasn't really done time to go back to clean out the data that were curated a long time ago without proper schema, documentation, and validating the quality of the data before they jump into innovation using AI. And this is a very common cause for failure of the projects. And one more point I want to add here is that you know, some projects, it's very important when we collect the data for testing and development. You want to make sure that your validation and test set come from the same distribution. I've seen this over and over. Some models were developed, you know, using some, you know, publicly available data set because, you know, within the organization, you don't have that data set. But then when you try to apply to your own use case, well, you just discovered that the model failed miserably. And there's no surprise, right? Because, you know, they come from different distribution, can expect model learn from a different data set to generalize well in your use case. So that's something to be careful about. And last thing is really paying attention to the innate bias in the data set. I keep saying this because to us, like JPMorgan Chase, this is a huge challenge, and we need to make sure that we're able to mitigate all the risk associated with the bias that are innate in the data set. And so for many projects, I think this is something worth thinking about from the get-go rather than putting this as an afterthought.
Excellent. If anyone else wants to weigh in, we can go for it. If not, we'll jump to the next topic. Sahar, you have anything, or you want to jump forward?
I think there, like, you know, good points were mentioned. Maybe I can add a couple of things shortly. And one is that I used to make the assumption of that the data exists, whatever that I want to use in the model, it exists. But very often you need to also not just look at the data quality, but whether, especially like, you know, in mobile domain, like, you know, looking at whether this is tracked and logged and what you're looking for, and if the definition of the data model is the same as what you're assuming when you're using the data. So for instance, whether there's been an adjustments for the time zone or not in the data. These are critical points before jumping into like looking at data that needs to happen. The other thing is that I think Gorkem also mentioned that, but thinking about what data we have, what infrastructure for model we have, thinking about ETLs around data that we need when we think about production, and also what kind of pipelines are like, more appropriate for scheduling and data collections on daily basis, or like hourly basis, and so on.
Excellent. Thank you so much, Sahar. Rachel, let's jump forward. Okay, Daniel, this question will be coming over to you. What is the best way to approach model implementation and training?
Sure. Again, this is a very large question with a very deep answers, but I'll just highlight some of the top points that I have here. One is, I think you need to set a very clear hypothesis or a set of hypotheses, and frame the problem properly. A lot of times I think I've seen teams jump prematurely, just say, oh, we're going to use classification. Oh, we're going to use this, very powerful state-of-the-art model, without really thinking deeply where there are other alternatives to frame the problem. So I think how you frame the problem basically decide the direction you're taking, decide the data that you need to be successful. So that spending the time to really explore multiple different framing of the problem and explore different hypotheses is important. The second thing I think is to make sure that you understand the data. Again, performing that comprehensive EDA upfront, so exploratory data analysis, to understand the data that you're using and understand how the data set was generated is key. You don't want to be surprised down the road when you're deep in model development, or even worse, when you have the results and find out that your understanding of a certain feature or attributes is incorrect. It's not uncommon to see data coming from legacy software were not properly designed, or designed with the wrong data types, or the interpretation may not be as intuitive as the users of data would assume. So definitely be very clear to spend time in understanding the data is the key. Now, once you have those, make sure you have a plan to develop a pipeline to be able to iterate through your model training and retraining. In the beginning, it's totally fine to be manual, but if you want to quickly iterate through, especially when you're deeper in the model development cycle, you're doing a lot of hyperparameter tuning, you're doing a lot of exploration. You want to make sure everything is streamlined rather than manually invoked. And it's not uncommon to see somebody make a mistake because they forgot to change some configuration, and then that whole couple hour or couple of days run is garbage just because you didn't their mistake was made. So usually I encourage my team to try to automate as much as possible and avoid hard coding things, because you could change in one place and missing out many other places, and that would cause a lot of waste time and also efforts. And I think most important is make sure the evaluation metric is established, so you know what you're optimizing for. Again, you don't want to be wander in the wild and not knowing where you're headed. You want to be very clear. So this kind of tied back to the hypothesis. Right? Once you have the clear hypothesis, you want to set the evaluation metric accordingly. And typically, I will encourage team to go with simple single value metric to optimize for, just because if you have like a lot of different metrics, it's very hard to interpret, and sometimes it's very hard to know what direction you're going to move towards. So it would be good to get clear on the evaluation metric upfront. So I think those are the key things, and then followed by error analysis. So don't blindly just try to push up the performance, really understand what type of errors are causing models to not be able to generalize, and try to classify or categorize different type of errors and identify the errors that will give you the biggest bang on the buck and focus on those errors first. And that way you have a very methodology to really systematically improve the model quickly.
Excellent. Thank you, Dan, so much. Sahar or Gorkem, either of you want to agree or disagree with Dan on implementation and training?
I maybe want to take a different tangent on that. So I totally agree with Daniel. I go a bit of more practical when you start with the looking at the training. One of the things is that I would like to see us not to overwhelm data scientists with building or machine learning researcher engineers with building a complex system or deal with a lot of production infrastructure, but rather start with looking at modeling. And I think there were also some statistics that most of the time of a data scientist is spent in notebooks actually. So spend, as Daniel said, rigorous time on data analysis, error analysis, but also maybe start having simple models in notebooks, which allows you to do deeper analysis. And when feeling more comfortable, go with and package this into a production pipeline and deal with those other parameters. That is one thing. And the other thing is, I think related to one of the answers or discussions on previous question, I think is important that when it starts the first iterations of training to look at what type of data we are giving to our model. So if a good practice is to subsample, and that's a straightforward thing. But sometimes it's not that straightforward when we are subsampling. For instance, if we are looking at a lot of different segments in our data, so we might have over-representation or under-representation in the subsample data. And it's very important to consider that when we are starting training our models.
Excellent. Thank you so much, Sahar. So we're just about out of time. If anyone would like to offer a last wise word, feel free. Otherwise, it's been a wonderful session, and I can't thank each of you enough. It was such a pleasure to hear all of you share your thoughts. Okay, we will wrap it up. Over to you, Rachel.
All right, thanks everyone. Attendees, it's time to make your way to your next session.